Alright, so this video is all about using and finding percents. Last unit we talked about converting percents into decimals and fractions. We're really just representing the same value in three different forms when we write it as a decimal, a fraction, and a percent. We're going to see that all three of those can be used to solve proportion word problems. We've seen this a little bit where you set up the proportion using the percent. You put the percent as a whole number over 100. That's part of the proportion that you'd set up. We'll also see that you can use that percent as a decimal to kind of shortcut some of these easier problems. Now, the problem with that method is that you really have to read carefully and pay attention to details. The problem with this one is it's a little bit more time consuming. So there's two different methods that we want to compare and contrast. Really, you just want to pick out which one you feel stronger with, and you can use that one. You need to be familiar with both, so it's important that you take notes on both sides. But really, you want to pick your favorite, and we'll kind of talk about the pluses and minuses at the bottom. We're going to start by just converting this 65% into a decimal and a fraction. We're going to go to the decimal first. We really just move the decimal place back 2 places. That's 0.065. That's as a decimal. You could also divide it by 100. That would give you that same decimal. To change it into a fraction, we're going to read the decimal place. That's 65 hundredths. That's the second decimal place. That's the hundredths place. So we put that over 100. You could also think about this as 2 decimal places past the decimal point. So we put it over a 1 with 2 zeros. Okay. Normally we'd want to simplify that fraction, but here we don't really care about that because we're just setting up the proportion with this, so we don't need to bother simplifying that. That's just to show that we can really convert between this percent and the fraction and decimal. We're going to use both of these in these two methods. Alright, so in method 1, we're setting up a proportion. Anytime we're given a percent, we always want to put the percent over 100. That is the easiest way to start these problems. When you're given a percent, you can always start the proportion using that. So basically what that's saying is that we're going to put the percent as a whole number, 30, divided by 100. This is part of our proportion. We need the other half. That part is x over 400. Now I knew the 400 was going to go on the bottom because this says what is 30% of 400? That's the total. We're trying to figure out 30%, some part of that 400. Okay, that's the total. That lines up with our 100%. We don't know what the 30% part is. That's what the question is asking. What is 30% of this bigger number? So it should be a smaller number. Here we're going to cross multiply. You multiply across 400 times 30, and then you divide by 100, and you get 120. Alright, so example 1b, we see the exact same problem. What is 30% of 400? So there's a separate way we can do this. We can change that into a decimal instead using the decimal 0.3. We can really read this as an operation of 400. Really means multiplying times 400. 30% of 400. Of really means multiply. So we're going to take that as a decimal and multiply it times 400. And that would give us that same 120. So it's 2 different ways of getting the exact same answer. 30% as a decimal multiplied times 400, that gives us 120. All right, example 2a, a waiter at a diner, I should say diner, was exceptional and deserved a tip. You want to tip 20% of the total bill, which was $42.25. How much should you leave as a tip? All right, so we immediately see that 20%. You see that percent sign, you know you can set up the proportion, at least half of it, as the percent over 100. So we're going to start off with that. Put the percent as a whole number, 20 over 100. Really, that just represents 20%. It's 20 divided by 100. That's where we're getting that part from. We see that we have a total here. It says of the total bill, which was this $42.25. That's the total. That's going to be lined up with 100. 100% means that's the total. We're trying to find out what the 20% of that is. So we don't know this matching number. We don't know the one that goes with the 20%, the tip part of this. We know the total. That's the 42.25. That's why this goes on the bottom. All right. We find out that after cross multiplying and dividing by 100, that x is 8.45. So what that really says is that we're leaving $8.45 as a tip. Example 2b, same problem. Again, that should say diner. We want to tip 20%. That as a decimal is 0.20. So we changed it to a decimal. And again, of the total bill is this number. Of that total bill means we're going to multiply 0.2 times that total bill number. That's the amount of tip. That's $8.45 again. Example 3a, you have a coupon for 18% off Jordans. If the original price is $120, how much money did you save? So we're trying to figure out the amount that we saved, the discount we got off of these Jordans. Okay, so again, percent off, anytime we see that percent, we're going to put that number over 100. It's going to be 18 out of 100, and that's going to line up with X out of 120. That 120 is the original price. That's the total. That lines up with our 100%. We cross multiply 18 times 120, divide by that 100, and we get that 21.60. That means we saved, or we had a discount of a little bit over $21. Again, same exact problem, solved in a different way. We're going to change this into a decimal instead of a fraction. We're going to change that into 0.18. We move the decimal place back 2 places. Starts out at the back of the number, ends up in front of the 1. Now this one doesn't directly say that we need to multiply those two numbers. The previous ones have said that word of. This one doesn't say that, but if we want to find 18% of this original price, we really just need to know in our heads that that's multiplication. So we're going to multiply that decimal times the original price of 120, and not surprisingly, we get the exact same discount amount, that $21.60. All right, the biggest benefit of the method on the left, setting up a proportion, is really that it shows you the math. It says that this number matches up with that. You know exactly what you found when you set up a proportion. That 18% is talking about the amount of discount. These two numbers are talking about the same thing. This is the discount percent. That's the discount number. This is the total amount, total percent. These two match up also. It shows you the math. It's very clear what your answer means. The drawback is that it's just more time consuming. That's really the benefit of this one. It's just quicker. If you understand how to set this up, this is very quick and easy. That's just multiplication. You don't need to write anything out like this. That one's very quick. The drawback, though, is that there are problems that are not going to be this simple, so you need to really read carefully and pay attention to detail. There's going to be times where they're not going to give us the total. Here, they're always giving us a total. On these 3 examples, they give us a total and made it nice and straightforward. It's not always going to be like that, so we need to really pay attention to details on those. All right, so what I want you to do is write down at least one more benefit or drawback of one of these. So you need to basically just fill in 1, 2, 3, 4, one of those 4 boxes, and then fill in the box at the bottom. Okay? Whatever. All right, on the back, again, we're going to be comparing these two methods using percents as a proportion and using percents. All right, on the back, we're going to be, again, comparing these two methods. This time we need to find the percent. They're going to be giving us two numbers, and we need to find the percent. On the left, it's going to be using a proportion. On the right, it's going to be using decimals. Really, it's still going to be kind of using a fraction, but we're going to convert it to a decimal. We're going to see that basically setting up a proportion is the exact same thing. It's just showing it in a different way. Okay. So example 1a says 50 is what percent of 35? That of really tells us that 35 is our base number. 50 is what percent of the total of 35. 50 All right, on the back, we're still going to be comparing those two different. All right, on the back, we're still going to be comparing the two different methods, setting up a proportion and using decimals. when we're dealing with percents. This time we need to find the percent. So we're going to be working backwards. They're going to give us two values, and we need to find the percent using those. All right, so on example 1A, it says 50 is what percent of 35. When we're asked what percent, we can actually start the problem the same way. We know we're going to put the percent over 100. So when they're asking what percent, we know that that's going to be our question. That's what we don't know yet. The x value, the variable that we don't know, is going to go over 100. We don't know that yet. That's what the question's asking. Now we have to figure out where this 50 and 35 go. We would think that 35 might want to go on top of the 50 because this number is smaller than that. But here it's saying 50 is what percent of 35. 35 is actually the total there. It's saying it's of 35 as the bigger number. That's our whole number. And it's 50 is some percent out of that 35. So it's 50 over 35. Here we would cross multiply 35 times x, and 50 times 100. We divide by 35, and we get that percent, 142.9%. Again, we can check to make sure this answer makes sense. That really does, because it's bigger than 1. It's about 1.5, 100, almost 150%. We should get the same thing using this as a decimal. Here instead, we're going to change that fraction, that same fraction. We still need to recognize that that is the fraction. 50 is some part of 35. It just happens to be bigger than one part of it. We're going to change that into a decimal just by dividing, and then change that directly into a percent by moving the decimal place back 2 places. We just divide it to go to here, and then we move the decimal place back 2 places to get back to this. Could also think about that as multiplying times 100. Example 2A says your original bill for dinner was $32.50. You left an additional $7.50 as a tip. What percent of the original bill did you leave as a tip? So again, what percent tells us that we are going to be setting a percent proportion. That means we can start off by putting basically just an x over 100. We know that the percent is going on top of 100. We know that the x is representing the tip percent. What percent of the original bill did you leave as a tip? So that has to line up with the tip that they're talking about, $7.50. That's what we left as the additional tip here. So those two need to match up, and $32.50 needs to match up with our total. That's the original bill. Okay, it's what percent of the original bill, and this is the tip out of the original bill. We cross multiply and divide by 32.5. You should get that we tip 23.1%. Example 2B is the same problem. What percent of the original bill did you leave as a tip? So again, we're looking for a percent. We're going to change this into a decimal somehow. We want to figure out how much of this original bill is the tip. So out of this total, how much is this? So it's 7.5 over 32.5 is a fraction. That turned into a decimal is 0.231. And we move the decimal place back 2 places. That's 23.1% again. Example 3A, at the bottom of your receipt from the grocery store, you notice it says you saved $8 using your card. If your final bill was $54, what percent of the original bill did you save? So here we really need to read carefully. It says that the final bill was $54, but we want to figure out what percent of the original bill we saved. So we're talking about two different bills here. The final bill is $54. That's including this saving of $8. So we need to take that back out to figure out the original bill. We are going to add these two back together. This was saved, so we need to figure out what it was originally. I'm going to show that over here. That's just adding those two. That gives us $62. That was the original bill. This is our final bill because we saved $8. We took $8 away from the original. When we're looking for the percent, we're going to set up the percent proportion using x over 100. We don't know the percent of the original bill, the percent of the total yet, but we know that that's 8 out of 100. That's how much we saved. This is the original 100% bill. And we figure out after cross multiplying and dividing by 62 that we saved 12.9%. We'd find the exact same thing out here. Again, this is some part of that total, that 8 out of 62. That's the fraction that we're looking for. What percent of the original bill did we save? This is how much we saved of the original bill. That is 0.129 as a decimal. That's just dividing. And then we move the decimal place back 2 places, and that's 12.9% also. So again, I think this method is a little bit easier on the right. It's a little bit quicker. But if you don't understand how to set up the problem, it can be very confusing. You really need to pay attention to detail and read carefully. You still need to read carefully for this method, but it works easily for every type of problem. It kind of sets itself up. Once you read the problem, you can set up part of it easily, and usually you can fill in the blanks from there. This is a little bit more of a guessing game if you're not sure how to do it. The drawbacks, again, still more time consuming. Again, I want you to do one of these 4. So you should really have already written down these 4 things. I want you to fill in an additional reason on one of these 4 and then write which method you prefer and why still.